Welcome back to the course. In this video lecture, I will be discussing the problems which were given in the tutorial number 3 of the EMF course. Coming to the problem number 1. The problem number 1 states that given that electric flux density is, this is the flux density, calculate the charge density at this point and also the total charge enclosed by the cylinder of radius 1 meter with Z value varying. Okay. Now if you carefully see what is given for us, given is D has been given. Normally D is a vector, so it will be having so I'll take first of all assuming because the first assumption itself is type of coordinate system. Now it is a cylinder, right? So I'll take assuming cylindrical coordinate system. So what I will do, this D bar must be is a vector, so it must be having 3 components. Now let's see, D bar, that is in this problem only Z component has been given, right? Z R cos square, the remaining components are 0. So given D has been given for us and he wants to determine, one is charge density, so I'll take it as rho V, and the total charge enclosed by the cylinder. So in total charge, so I'll suppose to compute Q. These two are to be computed and this has been given. Okay, so how to solve this type of problems? So I'll take this one as so this is the problem. Now in this problem, if you see, I will start with the basic shape of a cylinder. So this is the axis of the cylinder, and this indicates the radius, and this indicates the angle, and this indicates the height, right? So given D bar is UR component, it is 0, U5 component, it is 0. What is the only component which is present? UZ bar component is there, it is ZR cos square. Only one component is present. So in order to determine the charge density, I will employ this Gauss law, which is Maxwell's first equation. In differential form I will take. Okay. What is the Maxwell's equation, first equation in differential form for electrostatic fields? It is del dot D is equal to rho. So this is the Maxwell's first equation. Now we need to determine del dot D in order to obtain rho V. So we know del vector, since this is cylindrical coordinate system. This is cylindrical coordinate system, right? So in the cylindrical coordinate system, del dot D, what is del vector? Del vector is very simple. In cylindrical coordinate system, del vector is dou by dou R UR bar plus 1 by R dou by dou phi d phi plus dou Z by dou Z into D. So this is U5 bar, this is UZ bar. So del also is a operator which is in its vector format. These are the vector components across R axis, across phi, across Z. So now what I want is del dot D, right? This is the left hand side. I want del dot D. So dot product between this vector and this D vector. So what I will get? Similar quantities, it will become 1. UR dot UR, it will become 1. U5 will become 1. You know dot product, right? In dot product is equal to 1. all other will become 0. This is dot product. So this is r, this is r. What I will get? I will get this one into 0. Regarding phi, 1 by r dou by dou phi into here, what is it? It is 0, and here it is dou by dou z of what is present here. This is present. So divergence of a vector basically gives a scalar itself. So 0 plus 0 plus what is this one? Partial derivative with respect to z. So this remains constant. So only z will be there. So I'll get r cos square phi into 1. So what is my answer? R cos square phi. This is my what is this one? This is rho v, charge density. Now charge density has been obtained. So what is the charge density? So now charge density is equal to r cos square phi. So if you want charge density at particular points, he has asked to determine charge density at particular point. This is r, this is phi, this is z, right? So this is 1 into cos square pi by 4. What is cos pi by 4? 1 by root 2, right? So 1 into 1 by root 2 whole square. So what you will get? 1 by 2. So it is 0.5 coulomb per meter cube. The units are coulombs per meter cube for volume charge density. So first job is completed. Charge density has been obtained. Now charge enclosed by the cylinder. So B part is charge enclosed by cylinder. Charge enclosed by cylinder. This we are supposed to obtain now. So we are now charge density. So Q is equal to volume charge density into volume. Or else you can integrate it or the entire volume rho v. Okay. So for cylindrical system, what are the 3 dimensions here regarding the volume? So there are 3 dimensions become r, phi and z. Into rho v, this dv, differential volume for cylindrical vector, is given as r dr d phi dz. Okay, this is differential volume. So I have substituted here. So now I am supposed to solve this particular equation in order to determine the value of charge. So let's try this one. So Q is equal to integral of z, integral of phi, integral of r. What is rho v value which we obtained? R cos square phi into r dr d phi dz. So what you will be getting here? R will be multiplied here. So what I will get? It is z, it is phi, it is r square cos square phi dr d phi dz. So first of all I will do with respect to r, next I will do with respect to phi, and later on I will do with respect to z. So first of all, to do it with respect to r, what are the ranges of r? He has told that the entire cylinder has a radius of 1 meter. So minimum value of r is 0, maximum value will be 1. Entire cylinder, so phi value minimum is 0, it is 2 pi. And z value, it is varying from -2 to +2. So this is how we determine the limits. Okay, 0 to 1 of radius, 0 to 2 pi of angle, and -2 to 2 of z value. So first of all, let me do with respect to r. So I'll write this one like this. So I'll do this one. So I'll do the integration with respect to r. What is this one? This is r cube by 3 cos phi, where r is varying from 0 to 1. Here d phi is there, still dz is there. So if I substitute 1, what I will get? I'll get 1 by 3 cos phi. Minus, if I substitute 0, I'll get 0. So the answer is going to be 1 by 3 cos phi. So now Q is equal to integral z is equal to -2 to +2, 0 to 2 pi, So what I have got? 1 by 3 cos square phi. D phi, dz. Right. So I'll remove this one. Cos square phi, I can't do it directly, right? So what I should do? I should convert it this one into. I'll remain z is equal to minus 2 to 2. Phi is equal to 0 to 2 pi. 1 by 3 I have already sent it out. Cos square phi will be written as 1 plus cos 2 pi by 2 d phi dz. So first of all I am doing this particular one with respect to phi. So what I will be getting here? 1 by 3. 1 by 2 also I will take it out. So 1 by 3 into 2. Only this is remaining, minus 2 to 2. The rest of all integration. See what is integration of 1? It is phi. Cos 2 theta integration is minus sin 2 theta by 2. So the condition 0 is varying from 2 to 2 pi z. So what is the answer now? 1 by 6 integral z is equal to minus 2 to 2. What is this one? Initially I am supposed to place 2 pi minus sine. This will become 4 pi by 2. Minus, if I substitute 0, it will become 0 minus sine 0 by 2. Right, dz. So what is this answer? See, sine 4 pi by 2 is 0. This is 0, this is 0. So only what I will be getting, I will be getting only this value. So I will write it here. Q is equal to, already what is the answer which I had? 1 by 6, right? Q is equal to 1 by 6 is already there. Z is equal to minus 2 to 2. What I have got here, it is 2 pi, right? 2 pi dz, isn't it? So only this value is remaining here. 2 pi only remaining. So I have written as 2 pi. So 2 pi is basically a constant. So I will remove it and keep it outside. Z is equal to minus 2 to 2. If nothing is there, it is 1, right? What is integration of 1? It is z, right? So 2 pi by 6 z, where z is varying from minus 2 to 2. So what you will be getting? 2 pi by 6 into 2 minus of minus 2. So what? 4. 4 into 2 pi is 8 pi by 6. If I divide it by 2, 4 by 3 I will get it. So therefore, charge is equal to 4 by 3 by 4 units. It's a way how you are going to solve the problem using Gauss law and Maxwell's equation. In the next video lecture, we will see the second problem which we have discussed in the class. Thank you.